What's up, guys and girls? Welcome back to another episode of Meta Product. In this episode, I'm going to be teaching you database modeling and ER diagrams. Now, ER stands for Entity Relationship. Basically, we're going to visualize what our database looks like using some images. Why this is important is because when you have developers working under you, you need them to understand exactly how you want to structure the app. And as we learn in this episode, a lot of the ways that people and objects are structured in the real world are the same ways they're structured in code. What we have to do is we have to structure them into a database. Now, the most primitive form of a database is an Excel sheet, right? You can just look at an Excel sheet and maybe there's a sheet that asks you for your name and your email and blah, blah, blah. And what we're trying to do is we're trying to move that into a database, which is you can think of it as a way or a place to store this data without all the frills that Excel has. So none of the other tools, none of the toolbars, nothing like that. It's just basically a bunch of text files, right? So let's get on to the episode right now. All right, so database modeling and ER diagrams. So this is a very valuable skill for product managers to have. The way objects in the real world and how they're modeled in code are very similar, like we just spoke about. An entity relationship diagram is a map of all your models, and your models could be the users or the products or the bookings or whatever. It could be many different things that are integral to your app. Their attributes, for example, in the offline world, a user might have attributes like height and weight, but in the online world, we might not need those attributes. We might need attributes like their email ID and their username. So different attributes depending on the app that you're building. So their attributes and their relationships with each other. So a user may have many cars. So car here is an entity, user is an entity, but the relationship is what we're also looking at, right? And all of these entities and relationships are directly mapped into something called a relational database. You can think of a relational database as similar to Excel, except all the different sheets are connected to each other. And we talk about the connections too. A database has tables for each model. So each of our models, whether it's the user, the cars, the bookings, whatever it is, they're all called models. And there are tables for each model. And each table has many rows, right? So let's go to the next slide. So here's the thing. Let's assume there's an entity called a user, right? And there are many different relationships that a user can have with other entities. So let's look at another entity called cars. So we know here that Mr. Bean can have many cars. You can have a green car, you can have a blue car. Now the words green or blue, they are the attributes of the car, right? That's how you know one car is different from the other car, but the general model is a car. And we know that the relationship between Mr. Bean and cars is that one Mr. Bean can have many cars. Now, in the next slide, we're going to see that one Mr. Bean can only have one driving license. You can't have two driving licenses, but Mr. Bean can also have no driving licenses. So the relationship between the user and the driving license in this case is either 0 or 1, but you cannot have many. So these relationships make a lot of sense, especially when we start database modeling. We're going to do a few exercises. You'll see how this makes a difference. So this is cardinality. This is how you map relationships. And as you can see, there are 6 primary cardinalities. There is 1. There is many, there is one and only one, like in the case of driving licenses. There's 0 or 1, like you can either not having a driving license or you can have one driving license. You can have one or many. So you can have one, you can have many, you can have one and only one. A good example of this is a birth certificate, right? When you're born, you are given a birth certificate and you can't not have a birth certificate. And at the same time, you can't have 2 birth certificates. You can have just one. 0 or 1, which is the example of the driving license. Either you don't have a driving license or you have one. You can't have more than one. You can have one or many, which is the example of cars. Either you can drive one car or you can drive many cars. Or 0 or many, which is you can either have no cars or you can have many cars, right? So one way to understand cardinality, and people kind of confuse this, how do you map cardinality between 2 entities? And the best way to do it is to think in terms of maximums and minimums. So you should look at the relationship of entity 1 with entity 2 in terms of maximums and minimums at both sides. right? So an example of this, let's assume we're doing a user and a booking, right? Say a user goes to a platform and he's, booking a hotel stay. So we know that a user can come to a platform and not book anything. So the minimum number of bookings a user can make is 0. The maximum number of bookings a user can make is unlimited, is n. Let's just denote unlimited by n. So you can make as many bookings as you want. So either you do 0 bookings or you do unlimited bookings. You can do as many bookings as you want. So 0 to n. At the same time, a booking, on the other hand, should have a user. Without a user, a booking doesn't mean anything, right? A booking is only created when a user exists. So the minimum number of users required for a booking is 1, right? And the maximum number of users required for booking is also 1, because one booking cannot be shared by multiple users. If you and I had the same booking number and we went to a restaurant or a theater and we were both on the same seat, it wouldn't make sense, right? So one booking can only belong to one user, both from a minimum perspective as well as a maximum perspective. So here's how we denote it. On the left side, we have one minimum, one maximum. So one user can have either 0 bookings or more than one booking, or as many bookings as they want. So one user can have as many bookings as they want, and if they want, they can also have 0 bookings. So this is the idea behind cardinality. And how we denote this, I'll give you a simple method to denote this, is you just use these 3 things. This is how you denote 1, this is how you denote 0, and this is how you denote many. You can just replace it. And this is your cardinality map. This is how you denote the relationship between two entities. Right? Now, before we actually go on to doing some database modeling, I want to give you a quick idea that everything that you put in your database needs to have a data type. So you can't store a string, you can't store text in a data type which requires int, or a slot that can only take int, which stands for integer. So if something can only take a number, you can't put words into it. And if something only takes date, you can't put words into it, or you can't put numbers into it. So there are many different types of data types. You can look at all of them here on the left. It's up to you to choose the right one, right? So this comes with a little bit of practice, but I just wanted to keep you aware that when you do database modeling, it's important for you to have the data type in mind. All right, so let's model a few ER diagrams live using draw.io. All right, so this is draw.io. It's a free app. You can just go to draw.io and start doing it immediately. And what you should do is you should just open the entity relationship thing here, drop down here, and just pick the third table. There are 3 tables. There are 4 tables. You can just pick the third one and drag it here. What we're going to do in this episode is we're going to learn or we're going to model the relationship between a user and orders and products. So we're going to model something like Amazon.com, where a user comes in, he makes an order for something, and the order is related to many different products. So we're going to map the relationship between the 3. So we're going to call this table the user table, right? And this PK here stands for primary key. Now, I'll tell you the idea behind primary key. Say you and I are in the same class, and say both of our names was Varun. Now, if a teacher comes in and says, hey Varun, I need you to come out, which Varun is going to go out? Because both you and I are going to stand, right? So we don't know which of us is the Varun she's calling out. So Varun is not unique enough for us to use that as the primary key. The primary key is basically a unique identifier that pulls out one very specific record. It can't have 2 records coming out when you use it. In most classrooms, the idea of a roll number is the primary key, because roll numbers are not repeated. 2 students can't have the same roll number. So when a teacher comes in and says, I want this specific roll number to come out, then you won't have 2 people standing up. And we want to avoid the concept of having 2 people stand up at the same time. So the primary key, which is denoted in bold, is the roll number. So let's just generate a user ID, and this is going to be unique. So when a teacher comes in, it's like the teacher coming in and saying, hey, roll number 5, I want you to come out now. So that's what the primary key is about. So here the primary key is user ID, and let's put in some attributes. This is how you denote attributes, right? Let's say we want the user's name, we want the user's email, we probably want the user's sign up date, right? So just giving you some examples of what we want. And this is just your user table. Let me just did something stupid. Okay, this is your user table. Now let's introduce a new table, and we'll call this orders. right? And now, as we know, the primary key here is the order ID. We still need something unique. We probably want the order date. We probably want the price of the order. Total price, let's call it total price. We want the, maybe we want the region that the order is made in, or location, or maybe we could have the IP of the order. Doesn't matter, right? It's just, these are attributes related to the order. Now, what is the relationship between a user and an order? In general, we know that one user can come in and have 0 orders. But if the user wants, he can also have unlimited number of orders, right? You can just come in and, you can order something in the morning, something else in the evening, and something else for tomorrow. So a user can have anywhere between 0 to n orders. But at the same time, an order cannot exist without a user, right? Without a user, there's no sense of having an order. And at the same time, the maximum number of users for one order is 1. Just like in the hotel situation, with the booking situation, it is a 1 on both the minimum and the maximum for the number of users associated with an order, right? So let's denote that. All you have to do is to 1 mandatory to many optional, right? So we'll just map these two out. Just connect this, right? So we know that the minimum number of users for an order is 1. The maximum number of users for an order is 1. It doesn't make sense for an order to belong to 2 different users. And obviously, a user can have no orders, or they can have as many orders as they want, even including 1. They can have 1 order if they want 2. So the next thing is the products, right? Now, when I first started database modeling, this used to confuse me, and I'll tell you why, right? So let's have a product name. Let's have a product maybe model, and let's have a product maybe size, right? So this used to confuse me because I used to say, hey, why isn't the user model directly mapped to the product model, right? If there are bananas, why can't the user just buy bananas? And you can store in the in the bananas table which users have bought it. But the idea here is that you want to have the association between users and products via the order table. Because you can have one iPhone, and that same iPhone can be bought by many different users. In fact, a user can buy 2 iPhones in the same order. So which is why it is necessary for you to have an orders table in between, so that when you have many of one type of product, you want to map that together and clump it together inside orders, right? So you want to be able to make duplicates of products. In this case, the relationship between order and product should be something that we should think about right now. So an order at minimum has 1 product, right? If there are no products available, then the order isn't even started, right? How does it make sense if you have an order with no products? So at minimum 1 product, and at maximum you can have an unlimited number of products, right? So one order can have, you can just buy the entire store within one order itself, right? So the range again here is 1 to n, and on the other end, a product can exist without an order. Right? You could have made a new store, you have an iPhone on the store, and nobody's ever made an order for an iPhone, so you can have products without anybody making an order for them. And at the same time, one product can be in multiple orders, right? So you can have somebody who comes in and who orders an iPhone through his order, and then a different user who orders the same iPhone through another order, right? So it's just you make instances of the iPhone through the order. So the relationship here is this one, right? So you have 0 or many orders which belong to one or many products, right? And this is a simple kind of idea to understand. You can go revisit this slide and you can understand how this works, or you can go visit this slide and you can understand how it works. It's the idea of maximum, minimum, and minimum and maximum, which we've kind of mapped out here. Now that you have this,
Taylor and I'm from Lucid Chart. Walk yourself through that. You've built your...
All right, so now that you have this, you need to understand that users, orders, and products are now related. But the user model is related to the product model through the order model, right? It's not a direct relationship. Now, when you have one of these situations where, two things are related where one side has a one and the other side has a many, then what you do is you have to introduce the concept of a foreign key. Now we already know what primary keys are, they're unique identifiers, but there's the concept of a foreign key which essentially makes sure that you are able to map another table's primary key to yourself in order to be able to reference it. So think of the order like that teacher in the situation we spoke about who comes in and says, hey, I need product, I need you in, right? Oh, and I need to connect you to this user and I need you in. And to call out both the user as well as the product, you need the primary key of both because you can't use any other identifier because you might get duplicates. So what you do in this case is you add a foreign key here. And to do that, you can take one of these and just drag it here, right? So we're going to create a foreign key. I'm just going to type the word FK, words FK, or the letters FK, and then I'm going to introduce the idea of the user ID, right? And what I'm going to do is I'm going to denote that this is where the connection's at, right? So I'm going to say that the order has the details of the user. Now this way, when we have the order table, we can see which user ordered it, right? And then through the order table, we can find out the attributes of the user. At the same time, we have, and here it's fairly obvious, right? We have a 1:many, right? We know there's a 1 here and there's a many on this side. In this situation where it's also many to many, we have to look at which side has the 1. So we know that the product side has the 1. This line's on this side. So the foreign key again goes in the user ID, in the order table, right? So I'm just going to reintroduce this idea here, or reintroduce this foreign key here. And this time I'm going to call it product_ID, right? And I'm going to drag this so that we know where the relationships are at, right? So again, in both instances, the foreign key went in the order table because the order table is on the many side of things. So if you look at all these tables, for you to figure out where the foreign key goes, you should always look at which table is the child. But whenever there's an entity relationship or there's a relationship between two tables, you always have to figure out which is the parent table and which is the child table. The child table is always the table on the many side, right? So make sure you have the foreign key on the many side. And I'll tell you the advantage of having a foreign key like this. In something like Rails, let me just see if I can write in some text. Yeah, so in something like Rails, you can actually do, in a framework like Ruby on Rails, for example, you can actually do something as simple as order.user.name. So in this way, if you have an order ID, right, you can actually try and figure out which user the order belongs to and then figure out the name of that user. So you're not actually storing the name of the user in this table that's here, but you're referencing it via the primary key. So what's happening, if you want to visualize it, is that first, the backend is going to the order table. It's been given an order ID, and then it goes all the way to the foreign key and it says, I need to look for the user. And then, it jumps along the foreign key and then it says, okay, I've got to the user. Now we want the name. So it goes down to the name. So instead of you storing everything in one large table, the order, the name, the users, the products, everything in one large table, we make relationship tables, right? So that we're able to cross-reference among each other without storing everything in one place. So it's just, again, for separation of concerns. All right, guys. So, this was a basic demo of ER diagrams. What I need you guys to do is I need you guys to do a little homework. Right? There's some links attached to this which have a little more reading on ER diagrams, especially complex ones. You should take some of the examples, including, think about how the ER diagram for a user on Facebook would look like. How does a Facebook user have friends? How does he or she, like posts? How do they do comments? Right? How do they do long form posts? Right? So think about all that. Think about the relationship between those different entities. For example, a user is mapped to their own table via a friends table because a user is friends with other users. At the same time, a user can have comments, a user can have posts, but a user can comment and post on the same table. So you'll understand over time, especially as you do more ER diagrams, how you can actually make a lot of it leaner, easier, and well structured. Right? So the idea is that, you as a product manager should be able to explain visually to your developers what the app is supposed to be structured like. Thanks for joining me on this episode. Hope you do your homework. Catch you on the next one.